symmetry function. There are 10 symmetry functions. So I'm going to be teaching you how you can know the 10 and how you can derive the 10. Is that clear? So let's pick one after the other. Symmetry 1. The first one should know that anytime you see alpha plus beta, it's always what? Minus b over a. That's the first symmetry you should know. Symmetry 2. Anytime you have alpha dot beta, it's always what? C over a. That's symmetry 2. Symmetry 3. Now, this is where the work is. In symmetry 3, they will ask you to find alpha square plus beta square. They will ask you to find alpha square plus beta square. And how can you do this? Now, pay attention. Pay attention. I know most of you have memorized this thing. Even the alpha cube and the beta cube, everything, you've memorized it. And it's possible that you might forget in exam day. Pressure is very real. I hope you know that. So to avoid pressure, let's learn it. It's very simple. Now listen carefully. This can also be written as what? Alpha plus beta all squared. Do you agree? And you know, if you expand this guy, the goal of every symmetry, listen to me, the goal of every symmetry function is to end up having alpha plus beta, alpha dot beta. So when I expand this thing, will I end up having alpha plus beta then alpha minus beta? Let's see. If I should expand this to what will I have? I'm coming with, sorry. For this case now, literally what they told us in the textbook is that alpha plus beta, alpha square plus beta square is alpha plus beta all squared, isn't it? Minus what? 2 alpha beta. Now you'll be asking yourself that how did they get this thing? Look at the way they get it. Quick one. When you say alpha square plus what? Beta square. Are you seeing it? This can also be written as what? Alpha plus beta all squared. And if I should expand this thing like this, alpha plus beta, what will I have? Alpha square plus alpha beta, isn't it? Plus alpha beta or beta alpha plus beta what? Square. If you expand this. So this thing you expand, we turn to this. What's common here? Alpha beta. That's what? Alpha square plus 2 alpha beta plus what? Beta square. You can see. So that means if I should expand this thing, I'm going to have something like this. So how can I let this thing look like alpha plus beta, then alpha dot beta? Look at it carefully. This can be written as alpha square plus what? Do you agree to this? Then here is what? Plus 2 alpha beta. Remember, we said that if I should have, look at this now, is it forming alpha square plus beta square? Can I say, can I say alpha plus beta all squared? Am I right? Plus what? 2 alpha beta, am I right? Am I having sum? Am I having product? Do you agree to that? So when you get to this side, you must find a way you return back to this place. Look at it. You must find a way. Look at it. This is what I have when I expand this. When I expand this thing, this is what I have. But how can I go back this place? That's why they now said less minus what? 2 alpha beta. Are you getting what I'm doing? Less minus what? You know, if I should say minus, if I should put it here, minus 2 alpha beta, what happened? Cancel out, then return back to this. So yeah, is it kind of confusing? It's not confusing. It's confusing. A little bit complex. Let me come back again. This thing, if you write it this way, like the formula says alpha square plus beta square, is always going to turn to what? Alpha plus beta all squared minus what? 2 alpha beta. So I'm not trying to tell you that how do they derive this thing? Hello? I'm trying to tell you how do they derive this thing. If you look at this thing, this one, this is it. Abi? When I expand it, it's going to reach here. Isn't it? So this thing I wrote here, if I should bring it here, look at it, if I should bring it here, I'm going to have what? Alpha plus beta all squared plus 2 alpha beta, which is this, isn't it? Then the minus what? 2 alpha beta, This cancel what? This. Is it not coming back to here? Is it correct? It's correct. So that's how they did it. So don't need to cram things. Don't cram anything. It's when you have alpha minus beta all squared. Alpha minus beta all squared. Now this alpha, please, I beg of you, this is not like this. They are not the same thing. Note, you can do this. Alpha plus beta all squared is also the same thing like you can say this. Is that clear? But when for this case, you can't say it is like this. It's now alpha minus beta all squared. It is wrong. Is that clear? So good. So when you have alpha minus, okay.
You say alpha plus beta all squared. You don't take alpha squared plus beta squared.
Alpha
plus
beta all squared. Yes.
Alpha
Yes.
But let's say, for example,
Is a number?
yes.
Okay.
Like 2 plus 2 squared and 2 squared plus 2 squared.
Okay, let's say 2 plus 3, are we?
2.
Let's say 2. Here's 2, and here's what? 3. That's what? 6. Then 6 squared is 36, are we? Then here's 4 plus 9, 16. That's true. Thank you. Thanks for the correction. So that means, please, that means we cannot have, hello, we can't have alpha squared plus what? Beta squared to be what? Alpha plus beta all squared. It's wrong. Likewise, you can't have alpha, are you with me? You can't have alpha minus alpha squared, beta squared. You can't have it as what? Alpha minus beta all squared. It's wrong. Is that clear? You get it? So look at this now. Thank you very much. So look at this. If you look at this case carefully, I can try to expand this. And when I expand, what will I have? Alpha beta, isn't it? Alpha what? So what do I have? Alpha. No. That's different. That one is alpha square minus beta square. It's different. This one is different of 2 squares. But this one is, the two of them are all squared. Is that clear? So this case now, alpha, this alpha, open the whole alpha here. Then, open what? Do you agree to this? So what do I have now? Isn't it? What's common, please? Alpha square minus plus, what do you see? Yeah, alpha square, isn't it? This alpha multiply beta minus what? Alpha beta. Then this minus this beta multiply what? Alpha. The same thing as what? Minus alpha beta. Minus times minus plus beta times beta, beta square. These are the same thing, isn't it? What's the coefficient? 2 or 1. So minus 1 is what? Minus 2 alpha beta plus what? Beta square. So recall, I can rearrange this. Watch. This can come together. Turn to what? Remember this guy to be what? This. So when I try to input it, what will I have? All squared minus 2 alpha beta. This itself, this everything here. Then here we have what? Minus 2 alpha beta. Hello, will the minus sign affect this bracket? No. Why? Because it's after the bracket. And if it was before the bracket, it will affect. So what do I have? Alpha plus beta all squared minus 2 alpha beta, isn't it? Minus what? So what's common, guys? Minus 2 alpha beta, then what? Hence, what's the answer? Minus 4 alpha beta. So anytime you have this, it turn to this. Don't cram. Is that clear? Anytime I have what? Alpha in bracket, alpha minus beta all squared, it turn to alpha plus beta squared minus 4 alpha beta. I don't understand, my friend. Okay, where's your question? Minus 2 alpha beta, B. So very good. I hope you understand that when I expand this, it turns to this. Then this minus 2 alpha beta was outside. Do you agree to this? So you know that I said this minus cannot open a bracket because it's after the bracket. So because of that, I can open the bracket without the minus affecting it. So when I open the bracket, alpha plus beta all squared minus 2 alpha beta this side minus 2 alpha beta this side. Do you agree? Now, these are having the same variables. Alpha beta is here, alpha beta is here. Minus 2 minus 2 minus 4. That's why you can see there alpha plus beta square, which is this. Then this is written as what? Minus 4 alpha beta. And that's all. The goal, listen again. The goal is to find a way you have sum of the root. And what? If you go have an expression and at the end of your expression, you can't get sum of root and product of root, you're wrong. Okay? Minus 2 alpha beta. Why that hard then? Because this one, Abi? This one. You know, from this expression, when you expand this guy, it's going to come here. Alpha square minus 2 alpha beta plus what? Beta square. And now rearrange it by bringing alpha square and beta square together. And you can see now is rearranged. Then the minus 2 alpha beta that you're talking of here came out here. Then previously, before you come, or came rather, we already had this expression like this. We already had it that in bracket alpha plus beta all squared minus 2 alpha beta. So it means that any place I see alpha square plus beta square, I'll put what? This formula, which is here. This formula, you know, alpha square plus beta square. This is it. Alpha square plus beta square. And what is it? In bracket alpha plus beta all squared minus 2 alpha beta. So this formula is this. Is written here. Then your minus 2 alpha beta is now here. This minus 2 alpha beta was here. Then this one was from here. So when you leave the minus there, which is here, minus 2 alpha beta turns to minus 4 alpha beta. So that's how you solve it. Can we go on? I think it's kind of simple. Let's try symmetry 5. In symmetry 5, what if you have alpha square minus beta? Okay, before then, what if I have alpha minus beta? Yes, they usually ask this question also. What if I have just alpha minus beta? Very smart. Very, very smart. Recall, I like that. You are thinking very smart. Recall that this one, alpha minus beta all squared, is equals to what do we have here? Alpha plus beta all squared minus 4 alpha beta. And I want to get alpha minus beta, which is ordinarily here. So square rooting what? Square rooting both sides. What will it go on to? You know the square root of this. Then all the square root of this. Minus what? So what happened? So I left just alpha minus beta to be all the square root of minus 4 alpha beta. So that's the symmetry function for that. 6. This 6 or 7? 6. What if I have alpha square minus beta square? What's going to turn to? This is what we call difference of. It's called difference of two squares. So I have what? Alpha plus beta. Thank you. Have I gotten my sum already? Have I gotten my sum already? Where is it? But have I gotten this? But where can I see it? So we now say equals to what? Alpha plus beta, then square root of alpha plus beta square minus 4 alpha beta square. Very simple. So let's go to the one that involves the power of 3 and the power of 4. The one that involves the power of 3 and the power of what? 4. So let's try symmetry 7.